thank you for such a warm welcome. I'm thrilled to be here. It's great to be back in the mini dome, and it's great to be back at ETSU. I want to thank Katie Neal for that lovely introduction, and it's great to meet her mom earlier. I want to thank all the members of the Public Health Student Association. Dr. Randy Wyckoff, Dean of the College of Public Health, thank you very much for your kind words and for your great leadership. Provost Bert Bach, Mrs. Stanton, Mrs. Nancy Stanton, Mrs. Martha Culp, other distinguished guests, my longtime friends Elliot Moore and that guy she hangs out with, Carl Moore, and thank you, Elliot, for all your help in setting this up. Patsy Johnson and her husband, Judge Richard Johnson, longtime friends, and Patsy used to work closely with me when I was representing Tennessee in the United States Senate. Many, many other friends. I had a chance to visit with some in the reception earlier. I had a wonderful time recalling so many good times here and out at Elliot and Carl's place and over at the Peerless, and it was great to catch up. You know, it seems like a long time since I was representing Tri-Cities in the United States Senate. I was reminded of the passage of time recently. This is a true story. I was in Los Angeles with a business partner and sitting at well, it was called a soup and sandwich, and we were sitting on plastic chairs at a plastic table, having gone through the buffet. And this woman came walking past the front of my table, just staring at me. And I didn't think anything of it until a few moments later, I noticed out of the corner of my eye the very same woman was coming from the opposite direction, just staring at me. And so I looked up and I said, "How do you do?" And she took 2 steps and she said, "You know, if you dyed your hair black, you would look just like Al Gore." So I said, "Thank you." She said, "You sound like him too." I remember coming up here after 2000, somebody was reminding me I had a beard at that time, and oh, you know, that transition, just so you'll know, that emotional whiplash, I'll give you just a brief story about what that was like. Soon after I left my job in the White House, my wife Tipper and I were driving from our home in Nashville to a little farm that we have about 50 miles toward in this direction. And we were driving ourselves. I know that sounds like a little thing to most of you. But I looked in the rearview mirror, and all of a sudden I realized there was no motorcade back there. You've heard of phantom limb pain? This was a rented Ford Taurus. It was dinner time, so we looked for a place to eat, and we got off I-40 at the Lebanon exit, Highway 231, and looked around and found a Shoney's restaurant, low-cost family restaurant chain. Many of you are familiar with Shoney's. We walked in, sat down at the table, and the waitress came over and made a big commotion over Tipper. And then she took our order and went to the couple in the booth next to us, and she dropped her voice down slow. I had to really strain to hear what she was saying. And she said, "Yes, that's former Vice President Al Gore and his wife Tipper." And the man said, "He's come down a long way." So the very next day, continuing a true story, I got on a plane and flew to the continent of Africa, to the nation of Nigeria. And I made a speech in Lagos on energy. And I began my speech by sharing that story about what had happened the day before in Tennessee. And it's the first time I told that story, and I told it pretty much the same way I told it to you just now. Shoney's low-cost family restaurant chain. Tipper and I were driving ourselves, what the man said, and so forth. And they laughed, and I went on and gave my speech and went back out to the airport to catch a flight back to the United States. And I fell asleep on the plane until, in the middle of the night, we landed on the Azores Islands out in the Atlantic to refuel. And they opened the door, and I walked out on the platform there to get some fresh air. And to my surprise, there was a young man running toward the plane waving a sheet of paper saying, "Call Washington, call Washington." And I thought, here we are in the middle of the night, middle of the Atlantic Ocean. What in the world could be wrong in Washington? Then I remembered it could be a bunch of things. But what it turned out to be was that one of the wire service reporters in Nigeria had already written a story about my speech there. And it had already been printed all across the United States of America. And my staff was very concerned because the story began, former Vice President Al Gore announced in Nigeria yesterday, quote, "My wife Tipper and I are opening a low-cost family restaurant named Shoney's, and we are running it ourselves." I am not making this up. And before I could get back to the United States, the late night television comedians, Jay Leno and David Letterman, sometimes they're just not very funny. And this was one of those occasions. One of them had me in a big white chef's hat, and Tipper was scribbling and yelling at me, "One more burger with fries." 3 days later, I got a nice long handwritten letter from my friend and former partner Bill Clinton saying, "Congratulations on the new restaurant, Al." We like to celebrate each other's successes in life. Anyway, I'm telling you, it is so great to be here. This is such a wonderful institution, and your School of Public Health is up and already established in such a magnificent way. I remember the battles with working alongside former Congressman Jimmy Quillen and others, Democrats and Republicans working together for the benefit of this institution and now this great program. You are just about 2.5 years away from your 100th anniversary of the founding of the original institution. And of course, the department that became the focus on public health is really 60 years old. So there is a long tradition that has built into this reputation for excellence and outstanding quality in what you're doing here. So I congratulate you on that. And it's a great honor for me to be invited to give one of the Lamb lectures. I've looked at the previous speakers, and I'll do my best to match that distinguished group. And the topic you asked me to address is global warming and health, the health consequences of the climate crisis. And so I thought I would start, before zeroing in on the health consequences, by talking about the climate crisis itself. It is the largest and most serious challenge human civilization has ever confronted. And yet, we have not yet reached a point where the world's political systems are ready and willing to really do what's necessary to solve this crisis. And I do think that a full awareness of how serious this is is essential in order to get us across that tipping point so that the leaders of the world and the peoples of the world will support the bold and transformative action that is now clearly necessary. I think one reason why we as human beings have been slow to fully appreciate the magnitude and scale of this crisis is that nothing like this has ever happened before, and we have kind of an ingrained rule that causes us sometimes to confuse the unprecedented with the improbable. If something's never happened before, we're usually safe in assuming it's not going to happen in the future. Usually that rule works, but the exceptions can kill you. And this is one of the exceptions. You know, this is the 400th anniversary this year of Galileo's first demonstration in the salons of Milan of his new perfected telescope that had been invented 1 year earlier. But he made it better and used it to show people the moons of Jupiter and the rings of Saturn, and more importantly, he was able to see the true relationship between the Earth and the other planets in our solar system and the Sun. And of course, Copernicus had, 60, 70 years before that, had come up with this grand theory that explained the mechanics of the solar system. But he published his book as he was dying, so he never got hounded the way Galileo did. Galileo's assertion that the Earth goes around the Sun instead of the Sun going around the Earth was, if you'll forgive the phrase, an inconvenient truth back in those days, because he was then imprisoned and forced to recant. But the reason I tell you that story is Copernicus explained in his great masterwork why it is that we thought the Sun went around the Earth. If you get up in the morning and you look in a flat geography, the Sun rises in the east and sets in the west, and it looks as if the Sun's going around the Earth. But he explained that the distance from the ground to the top of the sky is very small compared with the distance of the Earth to the Sun, and he had it all figured out. He just didn't get the point across. But the reason I'm telling you this story is that a similar mistake, I believe, is part of the reason we've been slow to recognize the seriousness of the climate crisis. If you go outside and look up at the sky, it looks like a vast and limitless expanse. And it naturally leads to the assumption that there's no way that we as human beings could ever cause any serious change, much less harm, to the integrity of something so vast. But from the vantage point afforded us by the astronauts that have gone out to space, we can see that the atmosphere actually is very, very thin. It's only 1/1000th the thickness of planet Earth. The late Carl Sagan used to say, if you had a large globe covered with a coat of varnish, the thickness of that varnish relative to the globe would be about the same as the thickness of the atmosphere relative to the size of the Earth itself. So it is the single most vulnerable, critical aspect of the Earth's ecological system when it comes into contact with the incredible power of modern civilization. Now, it's important in understanding how the relationship between the human species and the Earth's ecosystem has been utterly and radically transformed in a short period of time. It's important to look at what's happened just in the last 100 years. The population of our planet has quadrupled in just 100 years. In fact, when I was born, it had just crossed 2 billion, and now it's 6.7 billion, roughly. And if I reach the demographic expectation of my generation, then I'll see it go to 9 billion or above. Now, population growth has made the overall impact of the human species on the planet much larger than it used to be. But population is beginning to stabilize because of public health and because of 4 factors that the demographers who have studied this so carefully, just in the last 20-25 years, they have come up with a real clear understanding of what stabilizes population. For those of you studying the sciences, it's an S-curve that goes from high birth rates and high death rates down to low birth rates and low death rates. And they used to think maybe it was putting factories in, because the industrialized countries seemed to have the low birth rates and low death rates, and that didn't work. And they thought about it in other ways, and then they finally figured out it's a complex system that moves from one equilibrium state to another, and there are 4 factors, all of which have to be present to make that population pattern shift. Number 1, the education of girls, by far the most important. Secondly, the empowerment of women. Third, the availability of culturally acceptable methods of fertility control. And fourth, the second most important factor, higher child survival rates. Because, as someone, a leader in the developing world, said a half-century ago, the most powerful contraceptive in a developing country is the confidence by parents that their children will survive. Where you have high child death rates, then the parents fear that their children will not grow into adulthood, so they have huge families. And when the child survival rates go way up, then most families feel comfortable in living out the preference for most families to have a smaller number of children. And the death rates come down first, and then a half generation to a generation later, the death rates come down. So I wanted to digress into that because some people say, oh, it's just a function of population. The climate crisis will be solved when we get population to stop growing. Well, it is slowing down, and it's going to stabilize, and we know what works. So part of the solution to the climate crisis is to have good public health programs that increase child survival rates and promote infant and maternal health, educate girls, empower women, and make culturally acceptable fertility control ubiquitously available. And everywhere in the world, we are now seeing a more rapid shift to lower birth rates and lower death rates than any of the demographers expected was possible. However, here we are with 4 times as many people already as we had 100 years ago. So that's the first factor that's changed the relationship between humankind and the earth. Second factor is more important. The scientific and technology revolution, which some say began with Galileo, others say it began 10 years later with René Descartes, who dreamed of a clockwork universe, and others say Francis Bacon, but it began a long time ago, and it has borne fruit in the Industrial Revolution and now in the still accelerating scientific revolution. And as a consequence, the technologically enhanced power in the hands of the average person on Earth has now been magnified 1,000,000-fold it's been magnified a lot compared to what it used to be. And you think about all of the powerful ways we can dig into the earth, all of the powerful chemicals that they know how to make now, all of the automobiles and trucks that are burning oil-based fuel, and you add up the impact of all these technologies, and what you get is a hemorrhaging of CO2 into the atmosphere. And CO2 is the single largest cause of the climate crisis, of course. Probably 2/3 of it is caused by CO2, and then you have methane and halons and all the chlorofluorocarbons in there and nitrous oxide. But let's talk about CO2 mainly, because it's by far the largest cause. And if we get a grip on that, we will be able to get a grip on these other ones. We've already focused well on some of the others. But CO2 is tough because it comes from all these machines and all these devices and all the new patterns that technology's made available to us. And these new things improve the quality of our lives. And CO2 is the exhaling breath of industrial civilization. So it's not an easy matter to confront. But we have to confront it. 150 years ago, two things happened. A Scottish scientist named John Tyndall discovered that CO2 molecules intercept infrared radiation. And that's not controversial. It's like gravity. It's there. It's real. And right away, people started wondering what's going to happen if we really build up the amount of CO2 in the Earth's atmosphere. It's going to trap that heat. And 112 years ago, a chemist named Svante Arrhenius in Sweden did 10,000 calculations by hand with a pencil and paper, and came up with the conclusion that if we doubled the amount of CO2 in the atmosphere, it would lead to an increase of about 6 degrees Celsius. And a lot of modern scientists thought maybe that was just a guesstimate and it was wrong. The closer they get in these global scientific analyses to what they feel is the accurate number, the more they go back to that hand calculation as being essentially right. So this has been known for a while. But 150 years ago, this year, something else happened. The first oil was discovered in Pennsylvania. And oil was added to coal as one of the two principal sources of carbon dioxide that we're putting up into the atmosphere. Now, there are three factors that have changed our relationship as a species to the ecosystem of our planet. I mentioned the first two: the population explosion, the technology revolution. The third is our way of thinking, because we've gotten so focused on short-term results, whether it's quarterly reports or overnight public opinion polls or sweeps weeks in the media. There are other cultural factors that come into play, but we have not been projecting and accepting responsibility for the long-term consequences of what we do in the present. So take an example. Venus and Earth are neighbors in the solar system, and they're almost exactly the same size, and no more than 400 kilometers difference in their radius. Been described as twins divided at birth. They both have a lot of carbon, but the difference is most of the carbon here on Earth is in the ground. But on Venus, a huge amount of CO2 is in the atmosphere. So what difference does that make? Same size, a lot of carbon. Does it matter if it's in the ground or in the atmosphere? Well, the average annual temperature here on Earth, average year-round, is 59 degrees, going up. On Venus, it's 855 degrees, and it rains sulfuric acid. Whatever the weather forecast was that worried you recently, it wasn't that bad. So this has implications for our current strategy of taking as much CO2 out of the ground as we possibly can, as quickly as we can, and burning it inefficiently to leave it up in the atmosphere. So we now have raised the concentration of CO2 in the atmosphere by a huge amount, from 280 parts per million, which is what it was before the Industrial Revolution, to 370, roughly, parts per million now. And that's a huge increase. And it's trapping much more heat. And the planet has a fever. And the temperature is still going up. Now, if you have a child with a fever, you first of all hope it goes away like a 24-hour bug. But if it's higher the next day and it keeps going up, you go to the doctor. And generally you take the doctor's advice, but you may want to get a second opinion. Well, we, humanity, went to this group that was mentioned, the Intergovernmental Panel on Climate Change, the 3,000 most distinguished scientists in the world in the different fields that are relevant to understanding the climate crisis. And for the last 20 years, they put out 4 unanimous reports. So we got an opinion, and a second opinion, a third opinion, and a fourth opinion. And now they're practically screaming from the rooftop saying, you all have to do something about this. You have to stop this because it's having extremely harsh consequences. And before I get to the health consequences, let me just mention some of the ones that you know. And that is, it causes more widespread, deeper droughts. And why is that? Because even a small increase in average temperature increases the soil moisture evaporation. And so you get, particularly in the mid-continent regions of the world, these massive droughts. And not too far to the south of here in southeast Tennessee and in Georgia and the Carolinas, South Carolina, you've seen this huge drought spreading in the American West, in California, and in China, Australia, and a lot of other places. One of the latest scientific studies warns that if we don't take action quickly, much of southern Europe will desertify because it's in that area where the tropics and subtropics are moving away from the pole because of global warming. Now the consequence is bigger floods. How could we have more droughts and more floods at the same time? Well, because the same increase in average heat that evaporates the soil moisture also increases the evaporation off of the oceans, which of course is where the hydrological cycle gets started. And so the average humidity everywhere in the world has gone up significantly because more moisture is evaporating off the oceans into the atmosphere. And that means that when storm conditions are present, they're bigger downpours and more of it falls at one time. And the places where it falls is being moved around a little bit. In some places moved around a lot. And so you get these giant floods. In North Dakota, they're fighting off record floods today. And we could go around the world and point out these extreme weather events that are occurring with regularity now. And the scientists always say, wait a minute, you've got to be careful how you say this, because you cannot say that a single event is caused by the climate crisis, because there are always multiple causes. But you can say that the odds of these extreme events occurring have shifted dramatically. It's like loading the dice to increase the number of times a particular number comes up. And the things they predicted would become a lot more common are becoming a lot more common. I was out in Iowa talking to the governor there, Chet Culver, and his emergency management people. They had 9 rivers at all-time record flood stage simultaneously last year. And one of them in Cedar Rapids exceeded the 500-year floodplain. The peak was 25 feet above what they had predicted. And for all these things to happen at the same time, they had an F5 tornado that was on the ground for 50 miles. And the people out there said they've never heard of anything like that happening. When you put more energy into a system, it becomes more energetic. So another consequence of the temperature going up is the melting of the ice. And in almost every mountain range in the world, the glaciers are melting and the snowpack is melting. And some of you know the phrase ecosystem services. I'm not going to dwell on this, but we tend to ignore all of the beneficial services that are provided to us free by nature. And one of them is, in most of these mountain regions, the predictable annual melting of the snowpack is the great free water storage system. And the state of California right now is worried about whether or not agriculture will survive in California, because the snowpack is 40% below what it should be, and the predictions are that all of the ice-covered regions there are going to lose ice. And this is most serious in the Andes and for the countries that get their drinking water from the Andes, and most of all in the Himalayas. Because on the Tibetan Plateau and in the Himalayas, they've got 100 times as much ice and snow as in all the mountains of Europe. And 40% of humanity gets half of its drinking water from that regular melting. And the great rivers of Asia, the Ganges, the Indus, the Brahmaputra, the Salween and the Irrawaddy, the Mekong down through Southeast Asia, the mighty Yangtze in China, and the Yellow River going up toward Beijing. All of them get most of their water from that snowpack. And so this is an incredibly serious challenge for humankind. The storms that come in off the ocean get stronger. And again, a hurricane like Hurricane Katrina could happen without global warming, but the odds of it happening went way up. And then 3 weeks later to have another Category 5 hurricane, Hurricane Rita. And look at how Haiti and the Caribbean were devastated this past year. And by the way, last November or last fall, there were 1 million people evacuated from New Orleans, and it barely made a blip, because that's the new normal, apparently. We're now seeing sea level rise accelerate because of the melting of the ice. And in places like Bangladesh, there are already climate refugees crowding into the cities because they have been forced to leave their homes in the southern part of that low-lying country. And they're used to floods. But the way the change comes is this. A flood that used to happen once every 20 years there is now happening once every 4 years. And the laborious task of rebuilding their lives, which they have learned to do once every 20 years, you have to do that once every 4 years. They get to the point where they say, we just can't do this, particularly with the sea level continuing to go up. Every 1 meter of sea level increase produces 100 million climate refugees. If Greenland were to melt, that would be 6 to 7 meters right there. If West Antarctica were to melt, that would be another 6 to 7 meters. If half of either melted, half of both melted, there you have got 450 million climate refugees in the world. There are other climate refugees. The Secretary General of the United Nations has pointed out that the tragedy in Darfur, where all that horrible genocidal violence has taken place, can be linked to one of its causes, that's the climate crisis, because the drying of eastern Chad and the virtual disappearance of Lake Chad forced all these people to migrate across the border into western Sudan, into the Darfur region. And there are people already living there, and so you've got an extra complication for all of the clashes that have led to this violence. And I mention that because it's no small matter for the world to think about hundreds of millions of climate refugees destabilizing political systems. But in some ways, the most serious of the consequences could turn out to be the health consequences. And here's what I would like to start by saying about the health consequences. Some of you have read the great book by Jared Diamond, Guns, Germs, and Steel. He is among the historians who have pointed out the key role of germs in the history of human civilization, and the fact that one of the reasons for the relative success of civilizations in the higher latitudes is that they were able to live and work in regions with frost, with cold winters, with cold nights, and so the bugs and the germs couldn't get at them all through the year, and they had relative insulation from some of the terrible diseases that are more commonplace in areas with huge virus and germ populations in the tropics and subtropics. And so what you get with the increasing temperatures is a shift of those disease vectors, whether they're insects or ticks or lice or whatever. They expand their range, and you find populations that have not developed immunities or resistance to these diseases all of a sudden being confronted with them. And it's not just laterally from the equator toward the poles, it's also vertically, because warmer air allows mosquitoes to go to higher altitudes. And in many places, the old timers would build their fishing camps above the mosquito line, their trout fishermen. And in Africa, cities like Nairobi and Harare were purposely located just above the mosquito line for that simple reason. They would have relative freedom from malaria and other mosquito-borne diseases. But now the mosquito populations are moving higher up the slopes, even as they move north and south from the equator. Moreover, the warmer temperatures multiply the numbers of mosquitoes. And this same phenomena happens with some of the other pests. You find that in the proceedings of the National Academy of Science, in a recent issue, they found that even a 0.5 degree increase, Celsius, 1/2 degree increase in temperature can translate into a 30 to 100% increase in mosquito abundance. This is called biological amplification of temperature effects. And the epidemics of malaria have been increasing. An estimated 750,000 to 2.75 people die of malaria each year. 75% of them are African children. Now, the populations that have lived for many generations in areas where malarial mosquitoes are common develop in infancy a level of resistance to that disease that makes them not immune to it, but when they encounter malaria the rest of their lives, it's uncomfortable and it's difficult, but it's not life-threatening in most cases. But the populations higher up the slopes or farther north who have not adjusted biologically to this threat, when they suddenly encounter malaria, then it is a very deadly disease. And so you're seeing this happen throughout many regions of the world. Not only in the tropics and subtropics, by the way. I was in Canada a year and a half ago. Well, I've been there since then, but this was a meeting where I was having a training program on the climate crisis for people to give this slideshow on the climate crisis. And some Canadian doctors came to visit with me, and they gave me an article from the Journal of the Canadian Medical Association. Very well done study, it appeared to be, and peer-reviewed, and they showed the fact that tick-borne diseases have been virtually unknown in Canada. But the increasing average temperatures in North America have moved the range of the ticks into Canada. And they can project decade by decade the numbers of tick-borne disease fatalities and and illnesses that will result from this. So one of the reasons I'm telling this story is that I was affected by the end of their medical association's study of this. They said, what our prescription for fighting these diseases is to get politically active and get our nation's political leaders to start doing something about global warming. That was the public health conclusion in Canada. So remember when, I'll give you a chance to applaud in a minute here. Thank you, I appreciate that. But remember, as I talk about these diseases, those of you who are involved with public health, don't separate your professional aspirations from your responsibilities as a citizen. They are connected. The practice of public health and the practice of medicine in the 21st century means getting active as citizens to insist that politicians do something to solve the climate crisis. So I ask for your help in getting that done. If you look at the macro relationship, the overall relationship between human beings and germs, there are four conditions that work in our favor and work against the success of the germs in infecting us. Colder winters, colder nights, stable climate, a rich web of biodiversity. Now you know the first two, colder winters and colder nights, interfere with the germ's ability to reproduce and the vectors that carry the germs. Stable climate is important because when there is disruption, these little critters have an evolution rate that is many, many times faster than large creatures like us. And so they adapt much more quickly to the disruption, and they move more quickly into the new targets of opportunity in the ecological niches that open up for them. What about the rich web of biodiversity? Well, when they are contained in sophisticated, interrelated webs of biodiversity, they are not as likely to come into contact with human beings. They're not as likely to spread out and migrate. When we go into the rainforest and cut it down and burn it, and all that's happening every year now, of course, 20 to 25% of the CO2 comes from burning forests around the world, and that's driven partly by poverty, partly by other factors. But when we tear it down, then human beings come into contact with some of these new scourges like Ebola, and it's been around a while, but you see stories from time to time about these things escaping. HIV/AIDS is a classic example, believed to come from the tropics in Africa. But these four conditions, colder winters, colder nights, stable climate, rich web of biodiversity, the climate crisis is changing all of those in the wrong direction. So the health consequences of global warming include a harmful change in the overall conditions that lead to health problems. Now, the health problems related to global warming that are often mentioned include deaths from heat waves, and that is one that has been written about quite a lot. I'll just say that the unprecedented European summer heat wave of 2003 turns out now, based on a brand new analysis, was responsible for many more deaths than they thought at the time. But a lot of things that people don't think about. West Nile virus. I never heard of West Nile virus when I was a kid, but it entered the United States just about 20 years ago, and then it spread quickly from coast to coast. And there are many causes of it, but the new conditions that eased its spread are among those causes. In addition to malaria, the most sensitive mosquito-borne diseases that are spreading as a result of the new environmental conditions are dengue fever and viral encephalitis. Lyme disease is another tick-borne disease that may already be spreading in part as a consequence of the new conditions that global warming has brought. The Journal of the American Medical Association has warned more than 13 years ago that waterborne infections and toxin-related illnesses such as cholera and shellfish poisoning may be increasing as a result of the climate crisis. Kidney stones, there was a recent study in the Proceedings of the National Academy of Sciences that points out the relationship with increased incidence of kidney stones. Now, all of these findings mean that we will need to put into place now, starting now, increased disease surveillance, integrated modeling, and the use of geographically based data systems to afford more anticipatory measures by the medical and public health communities. At present, the world is not equipped now, either in developed countries or in developing countries, for the emergence or reemergence of these diseases that are spreading because of the new conditions global warming have put into play, or the complex interaction of factors that can complicate these threats. But in closing, let me come back to where I began. In order to deal with the public health consequences of global warming, we have to deal with global warming, and we can. We don't have a lot of time to put together a global response, and luckily the world community is now meeting in December in Copenhagen to negotiate a treaty that covers this. But right here in the United States of America, we hold the key to the success of the fight against the climate crisis. And the reason's very simple. The rest of the world still looks to the United States of America as the leader of the world. And all of these other countries have been slow off the mark and have been comfortable looking away from this crisis, partly because they say if the United States didn't do anything about it, the United States of America didn't do anything about it, then why should we? If the United States of America does something about the climate crisis, then the whole world will begin to move. Now, the good news is our new president, Barack Obama, has put forward a very bold and very effective strategy for beginning to deal with global warming. And I didn't come here to make a political speech. I don't mean for it to come across that way. This should be a completely bipartisan concern. I don't understand why partisanship gets into it. I don't get that. You know, I understand that oil companies and coal companies and coal-burning utilities have a lot of political influence, and they spend a lot of money in campaigns and on lobbying. I think that's a factor, but it's hardly the only factor. You've also got some people who are philosophically determined not to let the government do anything, and they want to roll back the protections against the earlier forms of pollution that were recognized, and they can't imagine a new set of measures to deal with carbon dioxide. And the market system doesn't deal with it either because it's invisible, tasteless, and odorless. More importantly, it has no price tag attached to it. So it's out of sight and out of mind. We need to put a price on carbon. We need to integrate it into the markets. And it doesn't have to mean a tax increase. You can reduce taxes elsewhere by an equal amount. I know people don't believe that can be done, but it can be done. But one way or another, we have got to get the United States of America, our beloved country, to take the lead on this. Now, if we decide to do it, we can do it. You can take a patch of desert 100 miles on the side in Arizona or New Mexico and put solar panels on it. That patch would be enough to provide 100% of all the electricity the United States needs for the full year. in the world. More solar power falls on the surface of the earth in 45 minutes than the full energy needs of the entire world for a solid year. The wind power is also a tremendous resource. Eliminating waste, introducing new efficiency and conservation measures, the biggest new source. And there are many other ways to do this. We need to plant a lot of trees around the world to help pull it more quickly out of the atmosphere. Instead of burning the forest, we need to plant trees. These are solutions that we can put into effect. Now, for those of you who are students, consider this story. Before you were born, when I was your age, the age of some of you, President John F. Kennedy in 1961 announced that our country was going to put a person on the moon and bring him back safely within 10 years. And it was shocking to people to think that we could have such a bold vision as a country. And many people said, that's impossible. How could we ever do that? But 8 years and 2 months later, Neil Armstrong set foot on the moon and put the American flag right next to him. Now, on that day when he landed, in the control room in Houston, the average age of the systems engineers who were cheering there was 26, which means their average age when they heard that challenge was 18. Your generation is the one that needs to apply the pressure and give the ingenuity and the can-do spirit that our country needs to take this on and solve it. We can solve it. It is a public health threat. It is a threat to the future of human civilization. The fact that it's unprecedented, the fact that it has a global scale, the fact that it's happening so quickly, the fact that it defies our moral imagination, none of those are excuses. It's up to us. Years from now, the next generation will look back on what we did or did not do in these first years of the 21st century. And they'll look around them at a world transformed, for good or ill. If they see the North Polar ice cap, which has been the size of the lower 48 states for 3 million years, completely gone in the summertime, if they see these hundreds of millions of climate refugees, if they see vast areas turned into deserts, and public health threats completely out of control, if they see these other consequences that the scientists are telling us we've got to prevent, if they look around them decades from now and look back at us, they'll say, what in the world were they thinking? Were they distracted? Didn't they care? I want them to ask another question. I want them to look around their world and see a world transformed for the good, with public health measures all over the world that improve health and fights against the extreme poverty and disease and famine and suffering that's been a part of the human story since the memory of man runneth not to the contrary. It's time for us to get our act together and form a global bargain that takes on extreme disease and poverty and introduces renewable energy sources and plants trees instead of burning forests. And I want our children years from now to look back and say, how did they find the moral courage to rise up and solve a crisis that so many said was impossible to solve? It's up to us in our time, in your generation and mine. There's an African proverb that says, if you want to go quickly, go alone. If you want to go far, go together. We've got to go far quickly. And that means that all of us have to be a part of the solution to this crisis. Now, in closing, I want to come back to something I said earlier. I'm tremendously honored to be here on this occasion in this place at this great institution. And I told you I didn't want to say anything political. And what I'm about to tell you isn't political in the strict sense of the word, but in another way it is. I need your help. And I'm just as deadly serious as I can possibly be. We are on a knife's edge here. And the answer to the question that I posed earlier, will the United States provide leadership? The answer to that question is going to be given back to the American people by the Congress, the House and Senate this summer. Because there's going to be a big vote on President Obama's package. And it's going to be climate and energy and renewable sources of energy and a cap and trade system that helps us get a grip on the CO2, closing the carbon loophole. And these congressmen and senators are going to be hearing from the special interests that don't want any change in the status quo. They want to continue to be able to dump 70 million tons of CO2 into the Earth's atmosphere every 24 hours. That's what is going on right now, every single day. 25 million tons of it goes into the oceans, radically changing the pH level of the oceans, making the oceans more acidic. Virtually everything in the ocean that makes a shell has osteoporosis right now, because the higher levels of acidification that come from the 25 million tons of CO2 into the oceans every 24 hours is making them more acidic. And same thing, I met a coral expert on your faculty here earlier. Same thing is true of coral reefs. They make their reefs out of calcium carbonate. And just like these little shell-making creatures, including the little plankton at the base of the food chain, if they can't scavenge that calcium carbonate to make their shells, if the acid level is so high that it dissolves the shells while they're trying to make them, then that disrupts the food chain. Off the coast of California, for brief times in the summer season now, some of the seawater is actually so acidic it is corrosive. Large swaths of the oceans now highly depleted of oxygen, vast dead zones spreading. Now, this can be interrupted. We can choose a different course. But it really is up to you. I mean it. Those of you from Tennessee, Virginia, North Carolina, you're from all over the country. But your senators and your representatives are going to be hearing from these special interests. And it's going to feel to them like it's very tough to cast a vote to stop global warming for a variety of reasons. You know what's going to change their mind? If you really take what I'm saying to heart. I wish that I had the words, I wish I had the eloquence to find a way to transfer from my heart to yours the passion that I believe is appropriate for this turning point in world history. In my faith tradition, there is a verse of scripture that also appears in Arabic in the Quran. It also appears in Hebrew in the Torah. And in the words that I read, the passage goes, I present to you a choice between life and death. You must choose either blessings or curses. Some of the curses we would have if we make the wrong choice would be the public health catastrophe that I have talked about here this evening. But the blessings we can enjoy can be to take our human civilization to a higher level, where we don't only think about these short-term profit motives, but we think about the connection we have to one another. Not only those who are alive, not only those who are in our immediate family, but those who will come after us and those in other countries. We all have to make a choice between life and death, between blessings and curses. You really can make the difference. I hope you will. If we make the right choice, we have everything we need to solve this crisis. Some of the consequences are going to unfold no matter what. Some of them are already in motion, but the worst of them are not beyond the point of repair. The worst of them can be avoided. We can get our act together. We have everything we need to do the right thing, save perhaps political will. But ladies and gentlemen, in the United States of America, political will is a renewable resource. Thank you very much.